Hi viewers, welcome to my channel Education Shop. In this video we solve example 11.4 that is relevant about heating water in a counterflow heat exchanger from the book of Heat and Mass Transfer by A.Çengel 6th edition. Here is the statement of the example. A counterflow double pipe heat exchanger is to heat water from 20 to 80 centigrade at a rate of 1.2 kg per second. The heating is to be accomplished by geothermal water available at 160 centigrade at a mass flow rate of 2 kg per second. The inner tube is thin walled and has a diameter of 1.5 centimeter. If the overall heat transfer coefficient of the heat exchanger is 640 watt per meter square dot Kelvin, determine the length of the heat exchanger required to achieve the desired heating. From this shell side, this is the hot fluid input at a temperatures of 160 centigrade that is coming from the geothermal side and enter in this shell and then coming out at this point, and its temperature drop to T hot out, and that is not given, and we need to calculate that. The inside temperatures of the tube in which the cool water is flowing is 1.5 centimeter. The inside temperatures of the cool fluid is 20 centigrade and the outside temperature is 80 centigrade. Cool water flowing in this direction and the hot geothermal water is flowing in this direction. The cross flow occurs between the hot geothermal waters and cool waters, and heat exchange occur between it. Now let's come toward the statement. What's data is given in it. The cool temperature in is 20 centigrade. The cool temperature out, that is 80 centigrade. The hot temperature in, that is 160 centigrade. Here you can also see that. And the hot fluid out, outer temperature of the hot fluid, that is unknown to us. We need to calculate that in order to find the length of the heat exchanger. The mass flow rate of the cool fluid is 1.2 kg per second, and the mass flow rate of the hot fluid, that is 2 kg per second. The diameter of this tube is 1.5 centimeter, or in other words 1.5 multiplied 10 to the power minus 2 meter, because centi is equal to 110 to the power minus 2. We need to find the length of the heat exchanger. Now come toward its solution. Before starting the solution, remember the heat absorbed by the cool fluid is equal to the heat released by the hot fluid. Amount of rate of heat absorbed by the cool fluid is equal to mass flow rate of the cool fluid, the Cp value of the water, and the water Cp value is constant and it is 4.18 kJ per kg Kelvin. M dot C, and change in the temperatures of cool fluid, that is T out minus T in of the cool fluid. This enters the value and you will get the amount of rate of heat absorbed by this cool fluid. M dot C is 1.2, the Cp value is 4.18, and the change in temperature is 80 minus 20. Multiply this and you will get M dot C value, that is 301 kilowatt. Remember, this Q dot C is actually equal to Q dot H, and Q dot H is nothing but it is the amount of rate of heat absorbed by the hot fluid, that is equal to M dot H Cp, change in temperatures of the hot fluid, that is T in minus T out of the hot fluid. This simply enters the values. It is 301. The mass flow rate of the hot fluid is 2 kg per second. Cp value is 4.18. Inside temperatures of the hot fluid is 160 centigrade, and the T out temperature is need to calculate. Divide both sides by 2, multiply 4.18. This will cancel out. Solve this on calculators. It will give you the value of 36, that is equal to 160 minus T out of the hot fluid. Shift this to that side and this to that side. You can say that T out of the hot fluid is equal to 160 minus 36, and it will give you 124 centigrade. Next we need to find the log mean temperature difference. That is, for this first we will find the delta T1, that is equal to T hot in minus T cooled out. Inside hot temperature is 160 and cooled out temperature is 80, and it is 80 centigrade. Now delta T2 is equal to T hot fluid temperature out minus cool temperature of the fluid in, that is equal to 124 minus 20. Just solve and you will get 104 centigrade. And we know that log mean temperature difference is equal to delta T1 minus delta T2 divided by ln delta T1 divided by delta T2. What is delta T1? It is 80 minus 104 ln 80 divided by 104. Just simply solve this on calculators and it will give you the log mean temperature, and that is 91.5 centigrade. Next is to find the surface area. In order to find the length of the heat exchanger, we know that Q dot is equal to overall heat transfer coefficient surface area times log mean temperature difference. Q dot is 301. Overall heat transfer coefficient is given, that is 640. Surface area we need to calculate, and the log mean temperature difference is 91.5 centigrade. Divide both sides. 640 multiply 91.5. This will cancel with this. This will cancel with this. Divide 301 by this value and you will get the surface area of the tube, that is 5.12 meters square. But our requirement is to find the length of the heat exchanger. That's why surface area is also equal to pi d L. Then L is equal to surface area divided by pi d. What is surface area? That is 5.12. Pi value is constant and d value is given, and the value of d here you can see that is 1.5 multiplied by 10 to the power minus 2 meter. The solve this on calculators and you will get the length of the heat exchanger, that is 109 meter. This is our final answer. I hope you understand. If still there is revision, you can ask in the comments.